Let in var declarations. Note, Python for system programming mainly delegated to C. Hashtag let in var declarations. These are definition functions in Mojo equals greater than def function. Def function assigns a value to name that creates function scope variable. There are two challenges. 1. System programmers often want to declare that value that's immutable for type safety. 2. If variable is mistyped, it throws error. For this support, Mojo provides scoped runtime value. Let, immutable declaration, var, mutable declaration. Sample program of let and var declaration. Take a look at the sample program. Please pause the video and try to understand the logic. Now, we'll try to understand the logic. Explanation of sample program. The code is trying to assign a value to C, but it is immutable. So the code will error and stop executing. The code then tries to reassign B as C, but that won't work either because they are different values. The code first checks if C is equal to B, which it isn't. Then the code creates a variable called C and sets its value to be B before calling stuff. The code attempts to assign the value of B to C. Mojo based on MLIR. MLIR offers cutting-edge compiler and code generation system. Modern systems programming languages is the ability to build high-level and safe abstractions on top of these complex, low-level operations without any performance loss. In Mojo, this feature is provided by struct type. Struct function similar to Python class. Both support method fields operator overloading decorators and metaprogramming. The key difference here is Python class is dynamic, whereas Mojo is static type. Mojo bound to run at compile time and cannot add methods at runtime. Let's see an example for reference. Let's try to understand the logic of the struct code example. The code starts by declaring a struct called myPair. The first field is an int and the second field is also an int. There are two methods in this struct, _lt_, which returns a bool, and _la_, which returns a bool. The code starts by declaring that there will be two fields of type int, first and second. Then it declares the method _lt_, which takes one parameter of type myPair, returning true if self's first value is less than RHS's first value or false otherwise. Self's first value equals RHS's first value but self's second value is less than RHS's second. It then declares the method _la_, taking one parameter of type myPair, returning true if self's last value equals RHS's last value or false otherwise. Self has no last values. The code attempts to compare the first and second fields of two myPair structs. The code compares the first field of each myPair struct. Then it checks if the first field of one myPair is less than the others. If so, it returns true, otherwise, it returns false. Syntactically, the biggest difference compared to a Python class is that all instance properties in a struct must be explicitly declared with a var or let declaration. Use del to remove a method or change its value in the middle of running the program. Static nature helps in faster code execution. Mojo works well with Python operators under operator, overloading concept. All the standard types, like int, bool, string and even tuple, are made using Mojo. You might notice that we use int, with a capital I, which is different from Python's int, with a lowercase letter of I. This difference is on purpose, and it's actually a good thing. In Python, int type can handle really big numbers and has some extra features, like checking if two numbers are the same object. But this comes with some extra baggage that can slow things down. Mojo's int is different. It's designed to be simple, fast, and tuned for your computer's hardware to handle quickly. Interoperability. We want to get programmers who need to work closely with computer hardware, systems programmers, a transparent and reliable way to interact with hardware. We don't want to rely on fancy tricks, like JIT compilers, to make things faster. We want Mojo to work well with Python without causing any issues. By using a different name, instead of int, we can keep both types in Mojo without changing how Python's int works. Int is a struct that's included in Mojo's standard set of tools. Strong type checking. Mojo lets you use type checking. Type checking enable code to be manageable, secure and predictable. Primary way to employ strong type is Mojo struct type. Struct definition compile time-bound name. To know more about MIPI type feature, please visit the URL https://mypi.rethidocs.io/n/stable/. Let's take a look at the syntax or explanation of the given example. When you try to run the code, you get compile time error stating that 4 cannot be converted to mypair, which is what the RHS of mypair._lt_ requires. Python has syntactically identical features for MyPy type annotations, but they are not enforced by the compiler. Instead, they are hints that inform static analysis. Mojo optimized the code based on those types, pass values and registers, and efficient as C for argument passing and other low-level details. This is foundation of safety and predictability. Overload functions and methods. Mojo handle define function dynamically. Mojo offer full support to overload functions and method. Go through the syntax and try to understand the explanation. Explanation. The code is trying to get the value of a particular index in an array. The code first checks if the index is valid, and then uses that as a starting point for getting the value from the array. The _getItem_ method on array takes two arguments, self, which is an instance of array, and IDEX, which is an integer representing where you want to start looking in the array. If self has not been initialized yet, it will be set to none before calling this function. After checking whether or not there was a successful lookup at IDEX, which would return true, it returns whatever t was found at that position in the array. The code is to iterate over the array and return each value as a tuple. The code is to iterate over the array and return each value as an array slice. FN or function definition provide abstraction capabilities. Function limitations. Arg values default to immutable in FN body. Arg vales require type specifications. Implicit declarations of local variable disabled. Exception explicitly declared on FN with raise keyword. Mojo allows you to freely intermix def and FN declarations, for example implementing some methods with one and others with the other, and allows each team or programmer to decide what is best for their use case. Now let's discuss about copyInit and moveInit special methods in Mojo programming. Please find the syntax and example task given for your reference. Please pause the video and go through the syntax and example to understand the logic. Let's discuss the given example and its explanation. Explanation. The code starts by declaring a pointer to an array of 8 bytes. The code then allocates the memory for this array and copies the input string into it. The _init_ method is called when creating a new instance of the class, while _del_ is called when deleting an instance of the class. The data property on self stores a pointer to the allocated memory, which is freed in _del_. The code is a part of the implementation of the _init_ method. The code above allocates memory and copies data into it. The ownership of self is then transferred to the newly allocated memory, which will be deallocated when _del_ is called on self. Let's see another example of the _copyInit_ and moveInit_ special methods. Please find the explanation of the code syntax. The code is trying to assign a string value to the variable b. The code is assigning hello to the variable a, and then trying to assign that same string value, a, into the variable b. However, because my string doesn't implement _copyInit_, it will cause an error when attempting this assignment. The code should print hello and goodbye. The myString variable a is initialized with the string hello, and then assigned to the myString variable b. The myString variable b is then assigned to the string object a, which prints out goodbye. Why we need copyInit method to rescue. Take a look at the example. Now we will try to understand the logic. The Mojo compiler doesn't allow us to copy the string from A to B because it doesn't know how to. Here, my string contains instances of pointer. Mojo doesn't know what kind of data it points to or how to copy. To enable this, we implement the _copyInit_ special method. How to implement copyInit method? To enable implement the _copyInit_ special method. Please find the example and explanation logic. The value b equals a copy produces a logically distinct instance of the string with its own lifetime and data. The copy is made with the C-style strtup function as instructed by the lines of code above. Mojo also supports the moveInit method, which allows both Rust-style moves, which take a value when a lifetime ends, and C++-style moves, where the contents of a value are removed, but the destructor still runs, and allows defining custom move logic.